Chapter 8. Winds, Storms and Cyclones. Air is around us. We live on Earth, and there is a lot of air around us. Air is a mixture of colorless, odorless and tasteless gases. The layer of air surrounding the Earth is called atmosphere. Air exerts force on the Earth due to its weight. The pressure exerted by the air present in the atmosphere is called atmospheric pressure. In this chapter, we will study two important properties of air. Air exerts pressure. Air expands on heating and becomes lighter. Before we begin, we remember that the moving air is called the wind. Air exerts pressure. It is easier to ride a bicycle in the direction of blowing wind because the blowing wind exerts a pressure on us in the same direction in which our bicycle is moving and makes our bicycle move faster. On the other hand, we find it difficult to ride a bicycle against the direction of wind because in this case, the blowing wind exerts a pressure on us in the opposite direction in which our bicycle is moving. It makes it difficult for us to drive while moving against the wind. Similarly, while rowing a sailing boat, we find that it is easier to row the sailboat in the direction of wind. It is very difficult to row a sailboat against the direction of wind. When we are flying a kite, then the wind coming from our backside helps the kite to fly higher and higher. It is the blowing wind which exerts the pressure on the kite to fly higher. When air is filled in a bicycle tube with the help of an air pump, it inflates. Here, it is the pressure exerted by air filled in a bicycle tube which keeps the tube tight and makes the bicycle tube feel hard. However, if we fill too much air, the bicycle tube bursts because it cannot withstand huge pressure of air. Activity 1. To prove that air exerts pressure. Things needed: a tin can with cap, tripod stand, burner, cold water, wire gauge. Method: we pour a mug full of water in a tin can. Heat the water in the can by using a burner. Boil the water. When the steam comes out freely, stop heating and immediately screw the cap on it. Remove the can from the tripod stand and place it in the sink with the help of a thick towel. We pour cold water from a tap on the hot tin can. What do we observe? The tin can gets crushed as if a large force acting on it from outside has crushed it. When the water is boiling, steam is formed in the tin can. This steam expels all the air from inside the can. When the can is capped and cold water is poured over it, the steam inside it condenses and forms water. Since there is no air inside, vacuum inside, there is no air pressure. The large air pressure or atmospheric pressure outside the tin can crushes the tin can inside. Activity 2. To show air expands on heating and contracts on cooling. Things needed: a boiling tube, an uninflated balloon, 2 beakers, hot water, sticking tape, ice-cold water. Method: we take an empty boiling tube. It contains air, though we cannot see this air. Stretch the mouth of an uninflated balloon and fit it tightly over the neck of the boiling tube with the help of a sticking tape. We take some hot water in a beaker. Place the boiling tube having a rubber balloon fixed to its neck in the hot water for some time. We will see that the balloon gets inflated. Reason: when the boiling tube is placed in hot water, the air present in boiling tube gets heated, expands, and its volume increases. When the boiling tube is placed in ice-cold water, the air present in the boiling tube gets cooled, contracts, and its volume decreases. Conclusion: air expands on heating and contracts on cooling. Activity 3. To show hot air is lighter than cold air. Things needed: 2 empty paper bags of same size, wooden stick, thread. Method: we take 2 empty paper bags or empty paper cups of exactly same size. Hang the 2 paper bags in the inverted position with their faces pointing downwards on the 2 ends of a light wooden stick with the help of short threads. Tie a piece of thread in the middle of the stick. The other end of this thread is tied to a hook fixed in a rigid surface. Initially, the wooden stick is perfectly horizontal, showing that the 2 paper bags contain an equal mass of the same air, cold air. We put a burning candle below the open mouth of the left side paper bag. We see that after some time, the left side of the wooden stick goes up, showing that it has become lighter than the right side. Reason: when a burning candle is placed below the left side paper bag, the air above the candle flame gets heated. The hot air, being lighter, rises up and fills the left side paper bag after displacing the heavier cold air from it. Therefore, the left end of wooden stick becomes lighter and moves up. Conclusion: warm air is lighter than cold air. High-speed winds are accompanied by reduced air pressure. Moving air is called wind. It has been found that fast-blowing wind creates a region of low pressure. When the wind speed is very high, the roofs of huts or the tin sheet roofs of the godown are blown off. This is because when the high-speed winds blow over the roofs, it reduces the air pressure above the roofs. Thus, the higher air pressure below the roof exerts large force to lift up the roof, which can be blown away by the fast winds. The wings of an aeroplane are designed in such a way that air above them moves faster than the air below them. When the aeroplane runs on the runway, in order to take off, the air above the wings moves faster. The air pressure becomes very small as compared to the pressure below. The resultant upward push or lift makes the plane fly. Birds also fly in a similar way. Activity 4. High-speed winds are accompanied by reduced air pressure. Things needed: 2 balloons of equal size, stick, thread, water. Method: we take 2 balloons of equal size. Fill a little water into both the balloons to make them slightly heavier and more stable. Inflate both the balloons by filling air into them and tie their mouths properly with strong threads. Hang the 2 inflated balloons about 10 cm apart on a stick with the help of threads tied to their mouths. If we blow air or wind hard into the gap between the 2 balloons from our mouth, we see that the 2 balloons come closer. Reason: when the high-speed air moves through the gap in between the balloons, the pressure of air falls in the gap. The air pressure on the outside of the balloons, being higher, pushes the 2 balloons towards each other and makes them come closer. Conclusion: high-speed winds are accompanied by reduced air pressure. Activity 5. High-speed winds are accompanied by reduced air pressure. Things needed: a piece of paper, An empty glass bottle. Method. We take a piece of paper and crumple it to make a small paper ball. We hold an empty glass bottle on its side horizontally and place the small paper ball in the neck of the bottle, just inside its mouth. We blow air into the bottle from our mouth to force the ball into the bottle. The paper ball does not go inside the bottle. Reason: when we blow air into the mouth of the bottle, then the air in the neck of the bottle has high speed. This reduces the air pressure in the neck of the bottle. The air pressure inside the bottle being higher constantly pushes the paper ball out and does not allow it to go inside the bottle. Conclusion: high-speed winds are accompanied by reduced air pressure. Activity 6. High-speed winds are accompanied by reduced air pressure. Things needed: a strip of paper. Method. Hold a strip of paper 20 cm long and 3 cm inside between your thumb and forefinger as shown in. Blow air over the surface of the paper strip. We will find that the strip of paper lifts up. Reason: when we blow air over the surface of a paper strip, the fast-moving air creates a region of low air pressure above the paper strip. The air pressure below the paper strip being higher pushes the paper strip upward and lifts it up. Conclusion: high-speed air or wind is accompanied by a reduced air pressure. Wind currents are generated due to the uneven heating on the earth. The air pressure at that place is lowered. The cold air from the surrounding areas rushes in to fill its place. Air moves from the regions of high air pressure to regions of low air pressure in the atmosphere. The greater the difference in air pressure, the faster the air moves. Thus, wind currents are generated due to unequal heating on the earth. Thunderstorm. Thunderstorms develop in hot, humid, tropical areas like India very frequently. A violent storm with thunder and lightning is called thunderstorm. A thunderstorm is also known as an electrical storm. Generally, thunderstorms require 3 conditions to form: moisture, an unstable air mass and a lifting force. The sun heats the surface of the earth. The hot surface of the earth warms the air in contact with it. The warm air, being lighter, rises up, creating a low-pressure area. And cool air rushes in to take its place in the form of strong winds. If the air carries enough moisture, the moisture condenses when it comes in contact with colder air and forms clouds. We know that water vapor loses heat